Okay, so we're going to talk about chemical equations. So if we think back to some of the chemical reactions we've seen so far in this unit, during these activities we have observed color changing, bubbles appearing, and precipitate forming. We may have also detected odors being given off and energy being released in the form of light or heat. In some chemical reactions, matter may appear to be destroyed, but is this the reality? What happens to the masses of the reactants and products during a chemical reaction? That is what a French chemist named Antoine Lavoisier asked more than 200 years ago. So in the 1700s, Antoine Lavoisier placed a carefully measured mass of solid mercury 2 oxide into a sealed flask. When heated, the compound produced liquid mercury and oxygen gas. When the chemical reaction was finished, he measured the mass of each of the products, and he found that the total mass of the two products was identical to the mass of the reactants. So the 10 grams of solid mercury oxide broke down into 0.7 grams of oxygen gas and 9.3 grams of liquid mercury. So he concluded that the atoms in the chemical reactions were just rearranged, not destroyed. This conclusion is known as the law of conservation of mass, which states, in a chemical reaction, matter is not created or destroyed. If you start a reaction with 10 grams of reactants, you will end up with 10 grams of products. So if we look here, this is a beautiful example where they've put two solutions, one or both inside an Erlenmeyer flask, one inside a test tube, weighing it out. Once they mix them up, they still have the same mass. Everything still stays the same. Thank you very much for watching.